This is Chris, and we are taking a look at question 8 in Digital SAT Test 1 Math Module 1. So here we see a student-produced response, and they ask what is the positive solution to the given equation. So anytime we have a denominator, if we want to get rid of that denominator, we can multiply both sides times that value or times that expression. So here, if we multiply both sides by x plus 6, then it'll cancel out our denominator, and we'll be left with 55 equals x times x plus 6. Then what we'll do is distribute the x. So we have 55 equals x squared plus 6x. And this is starting to look like a quadratic. So here we can subtract 55 from both sides, and we get x squared plus 6x minus 55. And then to factor this out, we have to try to find something that will add to a positive 6 and then multiply to a negative 55. So there aren't a ton of factors for 55. 1 and 55, that's not going to work. How about 5 and 11? Hey, look at that. 5 and 11, we could figure out a way to get those to add to 6. If we did a positive 11 and a negative 5, then that'll work out. And that's exactly what we can do here, giving us two solutions. We have x equals negative 11 and positive 5. And what we're going to put in the box for our correct answer is going to be the positive solution, because that's what they're asking for in the question. They specify they want the positive solution. So we'll put in a 5 and move on to question 9. So here it says an airplane descends from an altitude of 9,500 feet to 5,000 feet at a constant rate of 400 feet per minute. What type of function best models the relationship between the descending airplane's altitude and time? Well, we know that we're descending. We're going down. So if we're going in a downward direction, then we can eliminate C and D, which talk about an increasing scenario. That would be maybe an ascending airplane, maybe one that's taking off. But here we are descending, so it should be something that's decreasing. And we just have to decide if it's going to be exponential or if it's going to be linear. And there's one key word in this question, and that's going to be right here. It's a constant rate. So if it's a constant rate, that lets us know that the relationship will be a linear relationship. And therefore, our correct answer for number 9 will be answer choice B. All right, let's take a look at number 10. If the given function g is graphed in the xy plane, where y equals g of x, what is the y-intercept of the graph? And basically, one of the first things we want to think of whenever we see y-intercept is we want to think of x equals 0. So that's what the y-intercept means when you're talking about a graph. So it's going to be wherever you cross that y-axis. So it's here, or down here, maybe even at the origin. But that's always going to be when your given x value is 0. So as long as we can make that connection, then we can go ahead and plug in a 0 for x. And if we weren't sure, our answer choices actually point us in that direction, because if we look over here, we actually see that all of our answer choices have a 0 in place of the x. So if you look at x comma y, every answer choice has a 0 there for x. So if we weren't sure on our own, there's maybe a little bit of a hint here that we can use to our advantage. And then from that here, we're going to plug in a 0 for x. So we'd have 11 times 1/12 to the 0 power. And hopefully we know our exponent rules, but anything to the 0 power is going to be equal to 1. So this is going to be 11 times 1, which gives us 11. So our corresponding y value is going to be 11 when x is 0, and that matches up with what we see in answer choice A over here. Alrighty, let's take a look now at question number 11. And here we see a circle, and it says, the circle shown has center O, circumference 144 pi, and diameters PR and QS. The length of arc PS is twice the length of arc PQ. What is the length of arc QR? Okay, so if the entire circumference is 144, then that means if we're looking, let's say, from S to Q, just this part of it, well, because they tell us that QS is one of the diameters, that means that that arc there would be half the circumference. A diameter cuts a circle in half, and so that entire arc would be 72 pi, be half of that 144 value. But it's broken up into two parts, right? And we're trying to figure out what each part is. So here they tell us that the arc for PS is twice the length of arc PQ. So if we call this one X for PQ, then we can call PS, this piece over here would be 2X. And that will allow us to solve for all the information that we need for this. So here, when we do that, we have a 2X plus X equals 72 pi. 3x equals 72 pi. And when we divide by 3, we get x equals 24 pi. So now we know that for these smaller pieces, just so it doesn't get too messy, I'm going to color code this a bit, but here, these smaller arcs, this would be 24 pi. And the larger parts, this would be 48 pi for that arc length. And since they're both diameters, then it's going to be the same relationship for SR and RQ. So this will also be 24 pi here, and 48 pi for this larger arc. And if we look at what the question's asking, it's exactly what they want, is this larger arc, which will be 48 pi. So we'll go ahead and bubble that in for answer choice B, and move on to our next question. And stay tuned, because in our next video, we're going to hop right into question 12. Thanks for watching.